Welcome back students for a new session on polymers. So in this session we are going to discuss about the formations of polymers. First of all, we are going to discuss some addition polymers. For example, polyethylene, Teflon, polyacrylonitrile. So we are going to discuss how they are formed as well as their uses. So starting from polyethylene, you will get LDP and HDP. As you know, LDP means low density polyethylene and HDP means high density polyethylene. And why the names are given so? Because in this type of polyethylene, branching occurs. Due to the branching, there is gap between the linear chains and hence the density is low. So it is known as low density polyethylene. In this quality, there is the linear chain. The linear chains are one after another, so there is no branching and hence the density is also high. So it is known as the high density polyethylene. So first let us see the low density polyethylene, where it is used. So the uses are, it is used as a thin plastic film bags. So the carry bags that you get in the grocery shops is the LDPE, low density polyethylene, and it is used in electrical wires for insulation, and then in the manufacture of squeeze bottles, toys, etc. Squeeze bottle means those bottles like shampoo bottles and then lotion bottles where you have to squeeze the lotion out or the shampoo out is known as the squeeze bottles. So now the formation, we have taken n number of the ethene molecule. Since it is polyethylene, the monomer has to be ethene. So n number of ethene molecule is taken and they are heated at a temperature 350 to 570 Kelvin under the pressure 1000 to 2000 atmospheric pressure. So you will get the chains of polyethylene. So next is the high density polyethylene. The production process is similar except that the temperature and the atmospheric pressure is different here. Here also n number of ethene molecule is taken and they are treated at heated at 333 Kelvin to 343 Kelvin under atmospheric pressure 6 to 7, and also in the presence of Ziegler-Natta catalyst. So Ziegler-Natta catalyst chemical name is triethyl aluminum and titanium tetrachloride. So this chemical as a whole is known as the Ziegler-Natta catalyst. It is the name of the catalyst. And then after heating this n number of monomer units, you will get the same type of polyethylene. But yes, the quality between LDP and HDP is very different. High density polyethylene is mainly used in the manufacture of containers. So you can see the dustbins or the storage boxes are made of high density polyethylene, and manufacture of pipes. The third type of addition polymers that we are going to study is Teflon or polytetrafluoroethylene. So poly means many, and what is the monomer unit? It is tetrafluoroethylene. This is the formula. Tetrafluoro means there are 4 fluorine atoms. So it is tetrafluoro. And since it is derived from ethene, it is called ethylene. So tetrafluoroethylene. So tetrafluoroethylene, when treated under high pressure and heat is provided, you will get the Teflon chain, F2C single bond CF2. It is same like the LDP and HDP, isn't it? So only the atoms are different here. Instead of hydrogen, here you will get F, fluorine. And its uses are for making the non-sticky utensils as a material resistant to chemical attack. So Teflon can be used as a container where you don't want that the chemical reaction occurs with the container or the polymer, and if you don't want that heat is affecting the container, then you can use the Teflon polymer for making the same. The next one is your polyacrylonitrile. So polyacrylonitrile. So the monomer unit of polyacrylonitrile is acrylonitrile, in short PAN, or the other name of polyacrylonitrile is Orlon. So here this is the acrylonitrile molecule, CH2 double bond CHCN. So here CH2 double bond CH2. So that is the ethene molecule. From the ethene molecule, one hydrogen is replaced by the nitrile group CN. And when this unit is treated with peroxide, you will get the polyacrylonitrile chain. So CH2, CH, and on this carbon CN is attached, and here you can go on adding, this side also you can go on adding the acrylonitrile monomers, and you will, if you are taking n number of acrylonitrile, you will get n number of the parts of the acrylonitrile chain. So polyacrylonitrile can be used as a artificial wool. So you can substitute the pure wool with the polyacrylonitrile and get a cheaper material. It can be used in the synthetic carpets. It is not the pure silk carpets or cotton carpets that you used to get. So it is the synthetic carpets. So next up is the condensation polymers. Under the condensation polymers, you will get three types of polymers, that is polyesters, polyamides, and formaldehyde resin. Polyesters examples are terylene and glyptal. Polyamides are nylon 6,6 and nylon 6. Formaldehyde resin is phenol formaldehyde resin, which is also known as bakelite, and melamine formaldehyde resin. So first we are going to discuss about the terylene or the dacron. So another name of terylene is dacron. So you have to remember both the names. So here the uses of terylene, you just see, it is used in safety helmets and for making magnetic recording tapes. So it is used in the materials made for recording tapes and also in the safety helmets. So let us see the preparation of terylene or dacron here. So what are the monomer units for terylene or dacron? It is ethylene glycol, which is also known as ethane 1,2-diol. So I'll explain the structure here. And the next monomer unit is terephthalic acid. So another name of terephthalic acid is benzene 1,4-dicarboxylic acid. So both these monomer units are mixed together and they are heated with a catalyst and at temperature 420 to 460 Kelvin, and you will get the terylene or the dacron compound. So here first of all let us understand the ethylene glycol. So ethylene glycol, you will get this ethylene is there, and whenever you will get ethylene glycol, just add 2 OH group on either side of the carbon chain 1, 2. So this is number 1, this is number 2, as we have already studied nomenclature, so I'm not going to go in details but just explain you the name here. So ethane is this part, and 1, 2, this is 1 and this is 2, you will get 2 all, so it is called diol. 2 means di and all means alcohol, prefix name is OL. The next one is your terephthalic acid. So here the terephthalic acid is a ring structure, and on the two ends you will get the carboxylic acid group. So it is called the benzene 1, 2, 3, 4. So it is 1,4-dicarboxylic acid. I hope you have understood, students. So ethylene glycol and terephthalic acid are the two monomers of dacron. So when you will react these two in the presence of a catalyst and at temperature 420 Kelvin to 460 Kelvin, you will get the terylene. So now the structure of terylene. So here you have to be very careful. As you know that condensation polymerization is going on, so you can see a removal of water molecule. So let us understand from where this water molecule has come. So you can see here I have marked in pink colors some parts of the chemical compounds. So from the ethylene glycol, if you remove the hydrogen here and from here, you will get what is remain? OCH2, CH2O, isn't it? From the ethylene glycol, I have removed the hydrogen from both the alcohol groups. So what is remain? OCH2, CH2O. Okay, so now this part is open for another polymer to add on. So I'll tell which polymer is added here. Okay, so this is the part. And then from the terephthalic acid, OH is removed from either side. From both the carboxylic acid group, OH is removed. So here carboxylic acid is C double bond O, OH, so COOH. So from this group OH is removed. So what is remain? This is remain C double bond O, benzene ring, again C double bond O, and then n number of water molecules. So you can see here one hydrogen and one OH. So one water molecule, again one hydrogen and one OH. So again H2O, again one water molecule. So water molecule is released here. I think so here. So here twice n water molecule is actually released. So if you have in the book n, please correct this part. So here you have got a part of ethylene glycol, and this is the part for terephthalic acid. Again here ethylene glycol will be added, and here terephthalic will be added. Moving in the series like AB, AB, AB. Now let us talk about the glyptal, which is another type of polyesters, falls under the condensation polymers. So it is used in the manufacture of paints, cements, etc. So as you know that the paints are mainly waterproof these days, so the polymers are being used here, and so glyptal is one of the polymers which is used in the manufacture of paints as well as some cements, etc. So in the production of glyptal, you have to again take ethylene glycol and again benzene dicarboxylic acid. But here one point you have to remember, that it is not 1,4-dicarboxylic acid, but it is 1,2-dicarboxylic acid. So as I have already explained the molecule of ethylene glycol, you know by now what it is and why the name is so, and benzene 1,2-dicarboxylic acid. So the both molecules will combine together and give us the chain of the glyptal polymer. So let us understand here again. From here hydrogen will be removed, and again from here OH will be removed. But the structure is a bit different here, since the placement of the 2-carboxylic acid is also different in comparison with the terephthalic acid. So you can see the structure here. So this oxygen will combine with this carbon. You will get oxygen carbon double bond, and you can rotate it and see that the structure will be like this. So now we are going to study about polyamides examples, that is your nylon. So two examples you have got, nylon 6,6 and another one is your nylon 6. So let us first see the nylon 6,6 polymer. So nylon 6,6 polymer is used in making the bristles of brushes. I don't have to say this, I think so. So bristles of brush, it can be toothbrush, or it can be some hard brush which is used for some other purposes besides brushing your teeth. And then it is used in making socks and sweaters. You already know by now that nylon is a type of fiber, so it can be used in making garments, it can be used in making clothes. So socks and sweaters can be prepared by nylon, and so many clothes you will get which is made up of nylon fibers or nylon threads. So now the preparation of nylon 6,6. Here two monomer is used, it is your hexamethylene diamine and adipic acid. Hexamethylene diamine. So hexamethylene means there is 6 methylene group in between the two amine groups, so it is called diamine. So here you can see the 6 methylene groups, CH2, 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 like that up to 6 numbers. You will get the ethylene molecule, ethylene group, and then you will get the NH2 on either side of the carbon at the end. So it is hexamethylene diamine, and this is the adipic acid. So here you will get the tetraethylene dicarboxylic groups. So here it is tetraethylene, it means there is 4 CH2 groups, and then at the end you will get the carboxylic acid groups. So the points that is marked in pink color is to be noted. From here one hydrogen is removed. What is left? NH is left, and in between both and in between it is exactly same. Again from here one hydrogen is removed, so you will get NH. So this is the hexamethylene diamine part. From here one hydrogen and from here another hydrogen. So what is left? NH then CH2 6 and H. So this is the hexamethylene part. From here OH is removed and here also OH is removed. So what is left? C double bond O, CH2 4, C double bond O. Is it clear? So and the nitrogen will be linked with the carbon. So this is the chain for nylon 6,6. So it is arranged in AB type. Once hexamethylene, adipic acid, again hexamethylene, again adipic acid, again hexamethylene, again adipic acid. So it is AB type of polymer. So one after other you will get the different polymers that you are going to add. And it is treated, you have to remember this point, 553 Kelvin and high pressure, then only you are going to get the nylon 6,6 polymer. So next one is your nylon 6. So it is used in making tire, cords, fabrics, ropes. So the purpose is actually the same, but it is used in different materials. It is also a type of fiber, so it is used in making fabrics, then ropes, nylon ropes are there, then it is used in making tire, cords. So in nylon 6 there is only one monomer. It is called the caprolactam. So when caprolactam is heated in presence of steam at temperature 533 Kelvin to 543 Kelvin, then you will get the aminocaproic acid. So how the aminocaproic acid is formed? When you are applying such high temperature, obviously the cyclic structure will break. The caprolactam will break at this point. And since you have used water molecule, there is 2 hydrogen and 1 oxygen. 1 hydrogen will go here and another OH will combine with this carbon. So let us see what is formed here. If you break the chain, it will become linear. In this form, you will get, it will become NH2. And then how many carbon centers are there? 1, 2, 3, 4, 5. And all these are what? CH2, CH2, CH2. So you will get 5 CH2 groups here. And then here we have added the OH. So it will become C double bond O, OH. So C double bond O, OH, COOH. So this is the aminocaproic acid. And when you will heat here, again the water molecule will be removed. So from here, the hydrogen is removed and from here OH is removed. Why we have added here first of all, this caprolactam is made into a linear chain, and then again it is the water molecule is removed. You will get the nylon 6. So we are done with today's session, and in the next class the polymer chapter will be over. So after which you will be provided with some tasks, and then we'll discuss some questions over here. So we'll meet tomorrow. Thank you.